Example 3.1. This is the same example that I have dictated in the previous lecture. A singly reinforced rectangular section has a width of 228 millimeter. Width is 228 millimeter and an effective depth of 450 millimeter. Not the height, the effective depth, that is 450 millimeter. Use concrete 18 concrete means 18 megapascal, and grade 420 steel means Fy is 420 megapascal. Calculate the design flexure strength for an area of steel equal to the following. Means these three sections are given. First portion of this question, calculate the moment capacity if the reinforcement area is 2 number 25 bars. Second case is if the number of bars 3 number 25 bars plus 2 number 15 bars are present. Third case is steel bars for balanced failure. We have to solve three cases. Okay, here is the data. B is the width, D is the effective depth. Okay, Fc prime is 18 megapascal. For this example, sorry, in the previous slides I have shown 17.5 megapascal, but that is 18 megapascal. Fy 420 megapascal, and modulus of elasticity of steel is 200 megapascal. We have to calculate the phi b mn moment capacity. First case is your area of steel 2 number 25 means 2 number 25. Here is a standard SI reinforcement bars. Okay, here 25 bar whose area of steel is 500. So here is 2 number 25 means 2 into 500, that is 1000 millimeter square. Second case is 3 number 25 plus 2 number 15. 500 into 3 1500. 15 is 200. Okay, so that will become total 1900 millimeter square. Third case is calculate the moment capacity based on balance failure. Okay, we will calculate the balance steel, then we will calculate the moment capacity based on balance failure. Okay, first of all, before solving, what we assume that before starting the capacity analysis, we assume that the current section is under reinforced. We will calculate A using A as Fy 0.85 Fc prime B. Here first case is case 1. Area of steel is 1000. Okay, 1000. Fy is 420. Fc prime 18 megapascal. B is 2 to 8 millimeter. You can calculate by yourself. A will come 120.4 millimeter. Then you will calculate the strain in steel. Okay, here is the formula for strain in steel: 0.003 beta 1 D minus A by A. Okay, you will put the value is coming 0.0062653. That is greater than yield strain 420 over 200 megapascal. Your value is greater than your strain in steel provided area of steel. Your strain in steel is greater than yield, so it means your section is under reinforced. Okay, and further your strain in steel is greater than 0.005, so that is a tension control failure. Your phi will be 0.9. So now all parameters are clear. You will apply the moment formula. Okay, phi as Fy D minus A by 2. As is 1000, 5.9, Fy 420. Okay, and D 450 minus A by 2. A is you have already calculated 120.4 by 2. Okay, you will divide by 10 raised power 6 due to megapascal. Your answer will be 147.3 kilonewton meter. So that's how you will calculate the moment capacity with the given reinforcement. Now the first part is complete. Now the second part. With reinforcement area of steel 1500 plus 400 means 25 bar and 15 bar. Okay, so first of all, again starting of the second part, we will assume this section is under reinforced. Okay, first of all we will calculate A. Here same procedure, A, and then we will calculate strain in steel. Here strain in steel formula. Okay, beta 1 D, all the values are given. I have put the values. you will get the strain value 0.00202, but the yield strain is 0.0021. Our strain in steel is less than yield, mean that is our enforced or compression control section. Now we will calculate the A by using this formula, by quadratic formula. Okay, in the quadratic formula we need rho. Our area of steel is 1900. We will divide by BD. You will get rho. You will put this all the values in this formula: FC prime, modulus of elasticity, reinforcement ratio, D, D, and beta 1. You will get the value of A. Okay, your value of A is 226 millimeter. Okay, so now you have calculated the A by using our enforced or compression control section. Now the moment capacity will be 0. Our section is compression control. Our phi value will be 0.65, 0.85 FC prime. Okay, FC prime is 18 megapascal. B 228 millimeter. A 226 millimeter. That is we have calculated. And 450 minus 226 divided by 2, and whole formula is divided by 10 raised power 6. Okay, your moment capacity is 172.7 kilonewton meter. Okay, that second part is also complete. Now in the third part, in the question it is asked that calculate the moment capacity based on balance failure. First we will calculate row balance. That is, we have also did the derivation for the row balance in the slides. Here is the row balance formula: 0.85 beta 1 FC prime over Fy, 600 over Fy plus 600. All the data is given. We have calculated the row balance. Now we will multiply it with BD. We will get the area of steel. Now we have the area of steel. Okay, now we will calculate A balance depending upon area of steel, which we have calculated based on row balanced. Okay, our A balance is 225 millimeter. Okay, so now at the end we will just calculate the moment capacity. Why we are using Fy? Because the balance failure is that failure where the failure will be simultaneous, as the steel is going to yield the same time concrete will crush. So we are using Fy, and that is definitely at the exact stage when the steel yield. Okay, the formula is 0.65 as here we have calculated 1869 millimeter square based on balance failure, multiply with 420. Okay, Fy 450 minus 225 divided by 2. The whole formula is divided by 10 power 6. Our moment capacity is 172.2 kilonewton meter. Okay, so that's all for this example. If you have any issue, you can ask the question at the end. Okay, so that's all. Have a nice day.